Yes. So, Srikal students, today we are going to discuss about the rotary motion in case of electric motor. Well, the credit of this goes to great scientists like Michael Faraday, who studied and developed the concept of electromagnetism, Hans Christian Oersted, the scientist who observed the deflection of magnetic needle when a current carrying conductor was brought near it. So many other scientists like Fleming, Maxwell, lot of people in series contributed, and today we have a lot of comfort in our life because it is because of electric motor that our fridge works. It is because of electric motor our AC, our fan of our laptop, our computer, our submersible pumps, right? In engineering, big pumps which can uh, which can do the work in HDR. Hot rocks are there, and they take out steam. They take out hot water from hot rocks. So it's all possible because of electric motor. Let us try to understand how electric motor produces rotary motion. Students, one is motor and other is generator. So interesting, students. In case of motor, what is the input, students? Anyone? In case of motor, yes. Motor, you have to switch the motor. You have to connect the motor to electric plug. That means current is the input of motor and mechanical power, or you can say mechanical work. This mechanical work is produced in terms of the rotary motion of shaft is the output of motor. This mechanical work is the input of generator, right, students? And the current is the output of the generator. So interesting. So generator and motor are reverse of each other. Now, students, in order to understand the rotary motion, the basic concept is this is the water tap. In case of water tap, we every day rotate it. We apply a couple on water tap. What is couple? Force F, and same force F applied by our hand by two different fingers in two different directions, in opposite direction. That gives the rotary motion to the head of the tap, and then you get water from here. Am I right, students? So you see, whenever you want to get a rotary motion, you basically, let's say there is uh, armature, or there is a rectangular coil. We say A, B, C, D. Students, just see, in case a downward force is applied on this end and upward force is applied on this end, what will happen? It will rotate. A downward force is applied at every point on the side AB, and upward force is applied on every point on this CD. What will happen? Can any student tell?
Let ring rotate clockwise.
Very simple, students. Just like imagine you are having a book, right? In this book, students, very simple. You know, let's say this book is, somehow fixed on this axis and it can rotate about this axis. Please try to understand. Let's say this is the axis of rotation of the book, and somehow imaginary axis is there, it can rotate about this. So imagine, students, if you apply downward force on this end, and if you apply upward force on this end, what will happen? It will rotate in which direction?
Clockwise.
It will see, this is coming, this side is coming down, this side is going up. So don't you think it's rotating in this direction? This side going down and this side going up. So this is anti-clockwise. So these two observations are important to understand, students, the working of electric motor. You will understand very quickly. Moreover, Fleming's left-hand rule plays a very important part in understanding how a motor works. Let's see it quickly. Students, Fleming left-hand rule says if this is your thumb, right? And let's say this is your front finger. This is your front finger, which is showing the direction of, yes, students, front finger,
Magnetic field.
direction of magnetic field.
See.
Magnetic, F for field, F for front finger, right? And your middle finger are stretched in such a way that your this thumb, which is showing the direction of motion. The direction of motion means direction of force. This is the direction in which force is being applied. This is 90-degree field, and this center finger is also having 90-degree. All these three fingers are mutually perpendicular to each other. That means angle between them is 90-degree. Well, you can stretch your left hand. This is your left hand, as proposed by the great scientist Fleming. Fleming's left hand rule gives us comfort zone to understand the working of electric motor. So students, if magnetic field, you see, is in this direction, and in case the, what is the direction shown by the middle finger? Middle finger, you can say as center finger. Center finger. So students, C for center and C for, yes,
Front.
C for current. If current is flowing in this direction given by the center finger, then the force will be applied because of this magnetic field, right, in a current carrying conductor, where the center finger is showing the direction of current. Magnetic field is in this direction, perpendicular to this, then the force will be experienced in this direction, right? So students, we can also say that these three are, vectors, and these three are mutually perpendicular. So once we have understood all this, I think it's not so difficult to understand the working of electric motor. In electric motor, students, we have two magnets. All right. Our ultimate aim is what? To produce, one force in the upward direction, one force in the downward direction. So that a rotation is there, just like shown on the water tap. So students, you just see, now I'm going to have two magnets, right? Two separate magnets I have. Well, these magnets, maybe you can say equal in size, equal in magnetic field also. So now these are two magnets, right, students? They are placed apart. Well, this is, what do you say, is like north, and this is south. And we know that, students, we can, without argument, tell that the magnetic field is from north to south, right? In this direction, this is the direction of the magnetic field, that is B. Now, students, here we are having in this, uh, we are having a what we call as a rectangular insulated copper coil, right, in the form of this parallelogram or in the form of a rectangle, right? It's placed in the magnetic field produced by north and south poles, fine. So now students, you see these copper insulated wire is in the form of this rectangle, and I say its name is A, B, C, D. Now you can exactly see, students, this side BC is along the direction of magnetic field. And this is your magnetic field, right? And your side AB and CD are perpendicular to the direction of magnetic field. I'm showing it little inclined, this droid, but this is a perfect rectangle. These angles are 90 degrees. All these internal four angles are 90 degrees. Now, students, you see these uh, this rectangular coil, which is there in the motor, is basically, you know, connected to. Give me a second. So basically, these are connected to, you know, these are stationary brushes, X and Y. X and Y are stationary brushes. Okay, now in these brushes, we have what we call as axle, which we want to rotate. So basically, students, this axle is there inside this, right inside this. I'll try to draw this. This is the axle. We basically are interested in rotating the axle. The input of the motor is what? Students, input of the motor is, come on, students, current.
Current.
Current. We we will supply the current by this battery, right? These brushes will be connected to battery, right? So here I have a battery, and then we can have a key also to switch on or switch off the battery. Well, this is your key, and this is your battery. Okay, students. So now we want current to flow in this direction. Okay, you may ask me, can it flow otherwise also? Yes, it can flow otherwise also. In the starting, we want current to flow in this direction. Obviously, it will flow in this direction. Then it will come back, in this direction. In this direction. This is the direction of flow of current. So, can any student tell me whether this will be positive or negative? This one, whether it will be small or it will be bigger?
The
Yes, bigger or smaller? Tell me fast.
Bigger.
Bigger, because beautiful. Because we say by convention that electrons flow from negative end to positive end. Current flows from so one cell. We can have two cell. We can have three cell. Any cell. Okay. So this is your battery. This is your positive terminal. This is your negative terminal. Obviously, current will flow in this direction. Okay. Now, student, this is your what we say. This is your axle, and we want axle to rotate under the effect of the magnetic field produced by north and south pole of magnet. Okay, this is north pole of magnet, this is south pole of a magnet. Okay, so this rectangular coil ABCD is completely under the influence of the magnetic field produced by the magnets. Okay, now students, there is a split ring here. There is a split ring. Why we have split ring? This split ring enables basically the rotation. So the inner portion of the split ring is insulated. Why? Why it's insulated? It is insulated because the current should not flow. The current from the wire ends at the brushes, and the insulation inside I can show with this color, with a different color, with this blue color. I'm showing the insulation inside the brushes. Okay, so the current from the coil doesn't touch the axle. Well, this is your axle, A, X, L, E. We want the axle to rotate. Okay, now this axle is free to rotate because of this arrangement of two brushes, X and Y. And this is point P on the axle, this is point Q on the axle. On P, different force will act. On Q, different force will act. Okay. Now, students, all of you can agree, if this axle is free to rotate in this, suppose there is a downward force on this P. Downward force means on all this complete side there will be downward force, and on this complete side there is an upward force. You agree that this will rotate or not? See, this is a small axle. Okay, suppose it is fixed, but it can rotate about this axis. Imagine. So on this side, you apply downward force. On this set, and you apply upward force. In which direction, Monrose, this axle will rotate? Please tell me. Left side goes down, right side goes up. Any student, in which direction axle will rotate?
The left side.
Left side. Left side means axle will go to this direction. No, it is fixed. It is fixed here. You should say axle will rotate in anti-clockwise direction. Okay. So now see how we are getting the force. All right. So now apply Fleming's left-hand rule. The direction of a magnetic field is this, right? Direction of magnetic field, right? Direction of magnetic field, students, is given by which finger?
First finger.
Finger will give the direction of magnetic field. Okay, beautiful. Now, in which direction the current is flowing? Just see.
Center finger.
It is flowing. Actually, imagine that you are having your chest, from your chest to the outer body, not towards your chest, away from chest. The current is flowing. So that we can now you try to twist the left hand side in such a way that your first finger shows the field, and the middle finger shows the current away from the chest. The moment you show it away from the chest, students, this is your middle finger, or you can say center finger, which is showing the current I away from the chest. See, this is away from the chest, not towards your chest. Here the current is towards your chest. Automatically, your thumb will point downwards. Your thumb will point downwards. Can any student show that, so that the students who view this video will get clear idea? Yes, any student can open the video and quickly show it. Otherwise, I will try to show in case my camera works. Okay, see that the Falcon core has shown correctly. This finger is showing field. This middle finger, center finger is showing current away from the chest of Falcon, and this thumb pointing downwards is showing the force. All right, thank you very much, students. Good. Hide video panel. So we have understood, students, that force will be acting downwards on this side, right? On every point on this side, the force would be acting perpendicularly downwards. So now here the force is acting downwards, and now let's talk about this side. Now this side CD current is in this direction. Now you change your left hand so that the direction of current is towards your chest. Automatically you will see the direction of current is towards your chest, the thumb will point upwards. And what does the thumb shows? Thumb shows, any students? Force. What is that force? Force means force causes motion. Okay, you see there's an object placed on the table. Unless you apply force, it will not move. Okay, or you have some evil spirit and all, then it can move. I don't know. Okay, fine. So what I want to say is that here the current is acting downwards. Here, I'm sorry, the force. And here on every part, the force is acting upwards. So what will happen? See, this is hinged here. Because this is hinged here, it will here downwards, here upwards. This will try to rotate in this direction. This thing goes upwards and this point goes downwards. So students, this is the way the rotation is created. Now, when this thing is moving, when A, B, C, D, when this moves in anti-clockwise direction, that effect is caused on this split ring also. The outer part of split ring is fixed with the brushes X and Y, and the inner part, you can search for SKF bearing animation to get a clear idea of how these brushes, this split ring is able to hold the axle. At the same time, it's allowing the rotation in the axle also. Please search on Google SKF bearing animation or simply internal bearing motion. Like that, you search something, it will show you animation how in case this bearing is there, and in this bearing small balls are there inside small balls are there, and then when axle is touching with this, the bearing is giving support to the axle. At the same time, this portion, outer portion is fixed, and internal portion, because of the balls, they move inside this. Beautiful, students. So this is what is happening, like the bearing, this ring facilitates the motion of axle, and the axle starts moving in the anti-clockwise direction. Students, this is the way the rotary motion is produced. This is the concept of electromagnetism. This is the base of electromagnetism. Some students will finding it very interesting, some very boring, very difficult. Why electro? Because there is electricity, there is current flowing because of battery in this rectangular coil. Magnetism, because the magnetic field is produced because of magnets. Students, very interesting. From sun, the radiations which are reaching earth, it's because of the radiations of sun that there is a living on life is possible on earth. Similarly, this light goes, illuminates whole Saurya solar system. So these are also electromagnetic radiations. Students, you must take this subject very interestingly. One day you might end up doing research in this, because you just think, from where this current comes in this and from where this magnetism is there. It's so interesting. Electromagnetic radiations coming from sun to the earth. And interesting things, sound, it needs medium to propagate. If there is no medium, you cannot, even if a person is standing close to you and there's no medium, you chillate raho, you keep crying, the other person will not hear. But electromagnetic radiations do not need any medium to travel. That's the reason they come so fast from sun. Even when there is a vacuum, I don't know if there is perfect vacuum or not, but let's imagine if almost nothingness is there in the space. From there also, these radiations travel at such a fast rate, the rate of 3 into 10 raised to power 8 meter per second. Okay. So students, wish you all the best. Have a nice time. See the video again.